Hello everyone, my name is Abhimanyu and today we are going to deal with trigonometry. Now, trigonometry I have divided into two sections, trigonometry ratios and trigonometry identities. So first we will see trigonometry ratio, then we will see trigonometry identities. Okay, now in trigonometric ratio what we will see? We will see what is trigonometric ratio, basic trigonometric ratio, complementary and supplementary trigonometric ratio, example related to ratio. What is trigonometric identity? Reciprocal trigonometric identity, Pythagoras trigonometric identities, double angle and half angle trigonometric identities, sum and difference for the sine and cosine trigonometric identities, examples related to that. Now, first we will see what do you mean by trigonometry. Okay, so here we can see trigonometry is made from a Greek word trigon. Trigon means triangle. Okay, and metry means measurement. So triangle measurement is related to trigonometry. So let's move. Now, what is trigonometric ratio? The ratio of the sides of the right angle triangle with respect to its acute angle are called trigonometric ratios. Okay. Now, ratio, it is trigonometric ratios are the ratio of the sides of the right angle triangle with respect to acute angle. Which acute angles? So, the acute angles that are present in a right angle triangle, those acute angles. Because one angle is 90 degree and other two are acute angles. Now, for that purpose, for finding out the trigonometric ratio, we have to select an angle of reference. Let us select an angle of reference theta. Theta is a Greek symbol used to denote an angle. So here angle of reference is theta. Okay. Now, so we have given a particular name for particular sides. So as we know that 90-degree opposite sides is hypotenuse. Okay, hypotenuse. And the angle of reference opposite side is opposite. And the left one angle opposite side is adjacent. So adjacent, opposite and hypotenuse are the sides name for the right angle triangle. Okay, to finding out the ratios of trigonometries. Okay, now as we know Pythagoras theorem is equals to p square plus b square is equals to h square. Now what is p, what is b? So opposite has other name known as perpendicular denoted by p. Adjacent has also other name that is b, base. Okay, and hypotenuse is denoted by usually h. Now if we change the angle of reference, what are the angle of reference here? Here is the angle of reference is theta. If we choose here angle of reference, this acute angle as alpha, then its opposite side is known as opposite. Okay, opposite, and its opposite side is hypotenuse. And the last one is the adjacent one. Okay, it is the adjacent one. So adjacent, opposite and hypotenuse are the names of the sides for a right angle triangle in a right angle triangle for finding out trigonometric ratios. Okay, let's move. Now, there are 6 basic trigonometric ratios: sine of angle A, cosine of angle A, tangent of angle A, cosecant of tangent, secant of angle A, secant of angle A, and tangent of angle A. So if we choose this angle as angle A, now A, it is the name of A, B, C. Now, as we know that sine of angle A is equals to what? Sine of angle A is equals to perpendicular by hypotenuse, or in terms of opposite, it is opposite by hypotenuse. Okay, opposite by hypotenuse. Okay, then next is cos of angle A. Cos of angle A is B upon H. That is what? Adjacent upon hypotenuse. Adjacent upon hypotenuse H. Okay, next is tan of angle A. Tan of angle A is what? P upon B. That is opposite by adjacent, or in other words, we can divide it with H. Then what we will get? So we'll get P by H upon B by H, and P by H is what? Sine of angle A. B by H is what? Cos of angle A. So tan A can also be defined as sine A by cos A. Okay, next is cosec. So these 3 trigonometric ratios are reciprocal trigonometric ratio. Cosec is the reciprocal of sine. Okay, so that is 1 by sine A is also known as cosec A, and sine A is P upon H, so it will be H upon P because it is reciprocal. Sec A is reciprocal of cos A, so it is 1 by cos A, and it is known as sec A. Sec A is what? It is B upon H. No, sorry, by mistake, it is reciprocal, na? So H upon B. Now, next is cot A. Cot A is 1 by tan A. Okay, and tan A is the reciprocal of cot A. So it is the cot A. And cot A is B upon P. Okay, so these are the 6 basic trigonometric ratios. Let's move. Now, next is complementary and supplementary ratios. So, sine of 90 minus theta is cos theta. Cos of 90 minus theta is sin theta. Cosec of 90 minus theta is sec theta. Sec of 90 minus theta is cosec theta. Tan of 90 minus theta is cot theta. So, cot 90 minus theta is equals to tan theta. Now, as we know that according to sign conventions, it is the first quadrant, as we know. It is the second quadrant. It is the third quadrant. It is the fourth quadrant, as we know all these things. Okay, in the first quadrant, all 6 trigonometric ratios are positive. In the second quadrant, just sine and cosec is positive, other 4 are negative. In the third one, tan and cot are positive and other 4 are negative. In the fourth one, cos and sec are positive, other are negative. As we know this. Now, as we know 0, it is denoted by 0 and 360. 360 is also 2 pi. So, it is 2 pi. Okay, so it is what? It is 2 pi. 0 comma 2 pi. And all are positive here, as we know. And all positive y axis is pi by 2. And in the second one, you know that sine and cosec are positive. So negative x axis is pi 180 degree. And in the third one, as we know, tan cot are positive. And negative y axis is 3 pi by 2, that is 270 degree. Okay, and in the fourth quadrant, cos and sec are positive. So these are the things we know. So as we can see that if theta is an acute angle, what we can assume that theta is equals to acute angle. Theta is equals to acute angle. If theta is the acute angle, then 90 minus theta is also acute angle. Okay, 90 minus theta will be acute angle. And if 90 minus theta will be the acute angle, it will lie on the first quadrant. So in the first quadrant, all 6 trigonometric ratios are positive. You can see here in the complementaries. So all complementaries are positive. Now supplementary, if theta is an acute angle, 180 minus theta will be in the second quadrant. And in the second quadrant, just you can see sine and cosec is positive, other all are negative. So sine and cosec is positive here. You can see here. And all other are negative. Okay. Now, so these are the supplementaries and complementaries trigonometric ratio. In supplementary, we can see sine 180 minus theta, sine theta, cos 180 minus theta, minus cos theta, cosec 180 minus theta, cosec theta, sec 180 minus theta, minus sec theta, tan 180 minus theta, minus tan theta, cot 180 minus theta, minus cot theta. Okay, so let's move. Now, we will solve these questions when we see identities, then we will come back again. So, what is trigonometric identity? So, basically, trigonometric identity is an equation. Using trigonometric ratio, when we write an equation, and that is valid for all, then it is known as trigonometric identities. So, there is algebraic trigonometric identities and not algebraic trigonometric identity, by mistake, algebraic and identities and trigonometric identities. What is difference between them? So difference between them is algebraic identity is what? Is basically a plus b whole square, like a plus b whole square is what? A square plus 2ab plus b square, as we know this. Okay, and trigonometric identities, let us take a trigonometric identity, Pythagorean one. So sin square theta plus cos square theta is equals to 1. Here we denotes what? Here the identities are functions. Which functions? Trigonometric functions. Variables are trigonometric functions. Sorry, yeah, variables are trigonometric functions. And here variables are there as a function. Okay, now, so reciprocal trigonometric identities, we have seen reciprocal trigonometric identities in ratios. And just we have to mention one thing here, that denominator should not be equals to 0. Otherwise, it will lead to undefined. So that's why here the denominator cannot be 0 for an equation. Okay, fine. Let's move. Pythagorean trigonometric identities. What is Pythagorean trigonometric identities? You can see on the screen. Sin square theta plus cos square theta is equals to 1 is then Pythagorean trigonometric identities. Yes. Okay. Then we can also see here that sin square theta plus cos square theta is equals to 1. Yes or no? So we can prove it with the help of trigonometric ratio very easily. Now, as we know that sin theta is p upon h. So p upon h whole square plus cos theta is b upon h whole square. Okay, now as we know that LCM will be h square, and in the numerator it will be p square plus b square upon h square. Now p square plus b square is h square according to Pythagoras theorem. So h square by h square would leads to 1. So what we got, sine square plus cos square theta is equals to 1. Okay, it's very easy. Now, if we divide by cos square theta on both sides, numerate LHS as well as RHS, then what we will get? The sine square by cos square would lead to tan square theta plus cos square by cos square would lead to 1 is equals to 1 by cos square theta is equals to sec square theta. So another trigonometric identity is what? 1 plus tan square theta is equals to sec square theta. Okay. Next, if we divide by sine square theta, then what we will get? We will get that it will be sine square by sine square will be 1. Cos square by sine square will be cot square theta. So 1 plus cot square theta is 1 by sine square, and 1 by sine square is cosec square theta. So it is also another Pythagorean trigonometric identity. So there are 3 Pythagorean trigonometric identities. Sine square plus cos square equals to 1. 1 plus tan square is equals to sec square. 1 plus cot square is equals to cosec square. Okay, understood? Next. Next is the sum and the difference identities for the sine and cosine. Now, sine of alpha plus beta is equals to sine alpha cos beta, cos alpha sine beta. Cos of alpha plus beta is cos alpha sine beta minus of sine alpha sine beta. Sine of alpha minus beta is sine alpha cos beta minus cos alpha sine beta, and cos of alpha minus beta is cos alpha sine beta plus sine alpha sine beta. Okay. Now, as we know that it has a many uses in trigonometries. How? If you can't find or you can't tell directly sine 120 value, that is 2 pi by 3's value. So you can write it as sine of pi by 2 plus pi by, for example, 6. Okay, pi by 2 plus pi by 6. Now, if you can't write directly pi the value, so you can write in this formula, then you can apply this formula as well as complementary rule as well. So if we apply this formula, then sine alpha cos beta, so sine alpha will be sine pi by 2, that is 1. Then cos beta cos pi by 6 is 1 by 2. Sine alpha cos beta plus cos alpha sine beta. So what would be the cos alpha? So cos alpha will be cos 90. Cos 90 will be 0. So 0 into something will be 0. So it will be, so sine 90 cos, that is its value is 1 by 2. Okay, got it? Let's move. So this is an example for this identity. Now there are identities for negative angle as well. If angle will be negative, then function will be negative for sine and tan. But in cos, it will be positive as well. And it is valid for reciprocal also. That is, sine of minus theta is minus sine theta. And if cosec of minus theta would be there, then it will be minus cosec theta. Cos of minus theta is cos theta, but cos reciprocal is sec. Sec of minus theta is minus of sec theta. Tan of minus theta is minus tan theta, and its reciprocal is cot. Cot of minus theta is equal to minus of cot theta. Okay, so these are some reciprocal identities. Now, double angle and half angle trigonometric identity, it's very easy. Now, sine of 2 theta equals to 2 sine theta cos theta. Double angle means 2 theta, half angle means theta by 2. Okay, now, so sine of 2 theta is equals to 2 sine theta cos theta. Cos of 2 theta is equals to cos square theta minus sine square theta. 2 cos square theta minus 1, 1 minus 2 sine square theta, and tan 2 theta is what? 2 tan theta by 1 minus tan square theta. You can also include here cos of 2 theta is equals to 1 minus tan square theta by 1 plus tan square theta. And also sine of 2 theta also you can include here. Sine of 2 theta is what? 2 tan theta by 1 plus tan square theta. Okay, these are some useful trigonometric identities. Now sine square theta is 1 minus cos 2 theta by 2. Sine theta by 2 is equals to 1 minus cos theta by 2. Okay, now cos square theta is equals to 1 plus cos 2 theta by 2. So sine theta by 2 is equals to plus minus, oh here is a mistake, plus minus 1 minus cos theta by 2. Okay, so tan theta by 2 is equals to plus minus root under 1 minus cos theta by 1 plus cos theta. Okay, next. So let us solve now. So cos theta by 1 minus tan theta plus sin theta by 1 minus cos theta. Okay, now what we will do basically is that here it is cos theta, here it is sin theta. Now we will break these also into cos theta, sin theta. So tan theta will be sin by cos, cot theta will be cos by sin, and then we'll take LCM. Okay, so here will be what? Cos minus sin, and one cos will go up, so it will be cos square theta by cos theta minus sin theta positive sine square theta by sine theta minus of cos theta, and we have to make the denominator same, so we will take minus common from here. So it would be cos square theta minus of sine square theta, and LCM would be cos theta minus sine theta. And as we know that a plus b into a minus b will be here, because it is a square minus b square, and a minus b will cut, and answer will be a plus b, that is cos theta plus sine theta. In competitive examination we have to mind calculation more, written calculation less. Okay, now in the determinants also we know that finding it that by producting diagonals like and subtracting it. So here will be cos square into cos square, that is cos power 4 theta by 2 minus sine square, so sine power 4 theta by 2, and apply here a square minus b square. What is a square? A square is nothing but cos square whole square, and sine square is sine square whole square, that is a is cos square theta by 2. Okay, so it would be a square minus b square, a plus b into a minus b. So a minus b is what? Cos square theta by 2 into sine square theta by 2, and a is the positive of it. If the positive of it means it would lead to what? It would lead to 1, because cos square plus sine square is 1 according to Pythagorean trigonometric identity, and it will lead to cos square theta by 2 minus sine square theta by 2, and that would lead to the half angle formula cos theta. Okay, so this way we solve. Next, move to back. Solve some questions more. Yeah. Now there is sine to alpha value. We have to find here sine to alpha value. So as we know that if 2 alpha have to assume as an acute angle. So 2 alpha is an acute angle. If then sine to alpha is 2 sine alpha into cos alpha. If okay, 2 sine alpha into cos alpha. Now as we know that 2 sine alpha into cos alpha. So what would be here? So here will be p by h, and here will be b by h, which is a factor of 2 as well. So h into h is h square. H square is what here? H square you can see is 25. So these two options is already eliminated, because it is not an even number, and it is not what? It is not a 25 as the denominator. So as we denote that p by h into b by h, sorry, so we can erase it. Yeah. Now, as we know that, what we know that it would be p by h into b by h. Okay, so p by h into b by h, it should be h square, and it would lead to the positive one, so we will give it like this. Okay, fine. Now, so that is the answer. How? Why h square is 25? Because h is 5, as we know that, and 3, 4, 5 are the triplets. So if p is 3, of course b will be 4, and there is 2 into 3 by 4 into 5 into 5. 3 by 5 is, for example, sine alpha, and cos alpha is 4 by 5. So 3 4s are 12, 2 are 24 by 25 is the correct. Okay, now move to the next question. It is 7 sine theta plus 24 cos theta is equals to 25. So it would be 7 by 25 sine theta if we divide by 25 on both sides, and it would be 24 by 25 cos theta is equals to 1, and we know that 7, 24, 25 are the triplets. Now if we compare this equation with sine square theta plus cos square theta is equals to 1, as we know that this is an identity. So sine theta is 1 here, but here is square, so it is also sine theta. So what is the value of sine theta we got? By comparing 7 by 24. Okay, 7 by 24. If we plus cos theta with it, what is cos theta will get? So cos theta will be 24 by 25. So 24 by 25. So it would lead to 31 by 25, and that is the correct answer for it, option number D. Okay, so that's it for this trigonometry. We will meet on the next video. Thank you.